China just built a train that hits 620 miles per hour, faster than a Boeing at takeoff. No wings, no wheels, just vacuum tubes and magnets. While the US tests prototypes, China's already scaling a system that could wipe out the need for planes. But here's the twist. The tech was invented in Germany. Now China owns it, and they're turning it into the fastest economic weapon on Earth. A train reaching 620 miles per hour sounds like science fiction, until China rolled out the prototype. This isn't some souped-up high-speed rail. This machine floats, literally. Instead of riding on wheels or steel tracks, it levitates, suspended in mid-air by a magnetic force field. There's no physical contact, no friction, no mechanical drag. And it's sealed inside a vacuum tube, so there's barely any air resistance. That's the secret, because at these speeds, air becomes your enemy. Push a train past 300 miles per hour, and resistance climbs exponentially. At 600 miles per hour, you're not just fighting wind, you're punching through what feels like concrete. Which is why, until now, no one could do it. But China found a workaround. They sealed the track inside a low-pressure vacuum tube, reducing air density to a whisper. That one move changed the math entirely. Now, magnetic propulsion pushes the train forward like a bullet fired through a tunnel. Only this bullet carries people. And unlike airplanes, it doesn't burn fuel or depend on runways, weather, or jet engines. At 620 miles per hour, you could travel from Beijing to Shanghai, a 750-mile trip, in under 2 hours. That same trip by car? Almost 12 hours. By conventional high-speed rail? Over 4. Even commercial airliners average around 4.5 hours when you factor in security, boarding, taxiing, and delays. China's Maglev shatters that. But it's not just about beating airplanes. It's about dominating global infrastructure. Because if China can scale this, and all signs suggest they will, the consequences ripple through trade, logistics, domestic travel, military readiness, and even global economic influence. But here's where the story turns. This record-breaking technology, the one that floats at the edge of sound, China didn't invent it. The original idea, magnetic levitation, came out of Germany, developed decades ago by German engineers who cracked the physics long before China joined the race. So how did China end up holding the fastest train on Earth? While the countries that created it were left behind, what happened next wasn't theft. It was something far more calculated. And it all started with a handshake deal in 2004. China may have the fastest train in the world, but the technology behind it didn't start there. The roots of magnetic levitation run deep into German engineering labs. Back in the 1960s, German scientists developed the first functional maglev systems. By the 1980s, they had built the Trans-Rapid, an operational train that could reach 268 miles per hour. Germany had a working model, a functioning test track, and a decades-long head start. But they never scaled it. Political debates, environmental pushback, and concerns over cost kept the system confined to prototypes and limited runs. The technology existed, but it was stalled by hesitation. Meanwhile, China was facing a very different reality. In the early 2000s, it needed to modernize its transportation system fast. The country was experiencing rapid urbanization and industrial growth. Highways were congested, airports overloaded, rail systems were outdated. China needed a leap, not a step. So, it reached out. In 2004, China struck a deal with German company Trans-Rapid International to build the world's first commercial maglev line. The result was the Shanghai Maglev, a sleek, high-speed line connecting Pudong Airport to the city center. The 19-mile route took just 8 minutes, traveling at nearly 270 miles per hour. But what mattered more than speed was access. Chinese engineers weren't just riding along, they were embedded in the project. Working side by side with German experts, they studied everything. The software, the mechanical systems, the levitation control, the safety infrastructure. Every bolt, every magnet, every circuit was reverse engineered and understood. It was a technology transfer. But not in name only. China didn't just buy a finished product. It learned how to build it. And then, it did what China does best. It scaled. Within a few years, Chinese engineers had absorbed the core principles of maglev and began developing domestic versions. Cheaper, more adaptable, and faster. They took the foundation laid by German scientists and pushed it further than Germany ever did. While Europe hesitated, China industrialized. While German trains remained on test tracks, Chinese trains entered commercial service. And while Western firms debated feasibility, China committed billions to making this vision real nationwide. That's how China came to dominate a technology they didn't invent. Not through theft, not through espionage, but through strategy, execution, and scale. And now, with the foundation set, they're building something the original inventors never dreamed of. A 620 miles per hour vacuum tube, Maglev network across an entire nation. For China, speed isn't a luxury, it's survival. With 1.4 billion people spread across nearly 10 million square kilometers, moving people and goods efficiently is not just about convenience. It's an economic necessity. Traditional transport systems, cars, trucks, even planes, can't keep up with the scale and velocity China demands. The country already operates the largest high-speed rail network on Earth. Over 25,000 miles of track crisscrossing cities, industrial zones, and rural hubs. But even these trains max out around 217 miles per hour in normal service. That's impressive, but not enough. The gaps between megacities like Beijing, Shanghai, Guangzhou, and Chengdu are still measured in hours. And in China's economic model, hours cost billions. Time equals productivity. In a hyper-competitive manufacturing and logistics economy, delays aren't just inconvenient, they're losses. Every extra hour spent transporting freight or business travelers is money left on the table. Every bottleneck in transit is a missed opportunity. That's why China isn't pursuing Maglev for prestige. It's doing it because faster transport unlocks real economic gains. Take the Beijing-Shanghai corridor as a case study. On traditional high-speed rail, that trip takes about 4.5 hours. With the Maglev system, it could drop to under 2. That time savings may sound modest until you scale it, multiply it across tens of thousands of trips per day, across logistics chains, labor mobility, tourism, and deal flow. The economic impact compounds exponentially. A faster network doesn't just reduce travel time, it increases economic connectivity. It effectively shrinks the country. Cities that once felt separated by geography become part of a unified, integrated market. This accelerates commerce, improves supply chain efficiency, and boosts regional development. And then there's the freight equation. Maglev isn't just for passengers. China is already exploring vacuum-sealed cargo lines to move high-value goods at jet speed, without the airports, customs lines, or airspace restrictions. For a country positioning itself as the backbone of global manufacturing and distribution, this is a tactical upgrade. It also fits perfectly with China's dual circulation strategy. A push to grow domestic markets while still dominating exports. High-speed internal logistics are the missing link. All of this makes one thing clear. China doesn't just want the fastest train. It needs it, because in the 21st century, the nation that controls speed, controls trade, controls time, and controls the future. And while other countries debate, China is building a train that floats is hard. Making it go 620 miles per hour is harder. But keeping it stable at that speed, inside a vacuum, across hundreds of miles, that's a different level of engineering altogether. At the core of China's ultra-high-speed Maglev system is a vacuum tube infrastructure, sealed, pressurized, and fine-tuned to microscopic tolerances. Why the vacuum? Because at extreme speeds, air becomes your biggest obstacle. Push a train past 300 miles per hour, and you hit a wall of resistance. At 600 miles per hour, it's like trying to sprint through a hurricane. The energy required to overcome drag becomes exponential. So China's solution is simple in concept, brutal in execution. Remove the air. Seal the track in a tube. Suck the pressure down to a fraction of normal atmosphere. That means less resistance, more speed, and higher energy efficiency. But the moment you start sealing a tube the length of a country, physics starts fighting back. Temperature fluctuations cause metal and concrete to expand and contract. A 100-degree swing can stretch a mile-long segment of tube by several feet, enough to cause alignment failures or structural stress. In earthquake zones, even a few millimeters of movement can throw a levitation system off balance. Inside the vacuum tube, there's no margin for error. At 620 miles per hour, the train travels over 900 feet per second. If anything is misaligned, by even an inch, it becomes catastrophic. Then there's the challenge of maintaining the vacuum itself. The system relies on massive pumping stations spaced along the route, each working constantly to extract air and stabilize pressure. If one fails, the entire section risks depressurization, forcing emergency stops and safety shutdowns. And safety at this speed is no joke. You can't just slam on the brakes. Emergency deceleration at 620 miles per hour generates extreme heat and requires miles of braking distance. To mitigate risk, China's engineers are developing redundant systems. Multiple pumps, triple redundant sensors, dynamic alignment tracking, and real-time AI monitoring. The trains themselves are designed to detect anomalies and self-correct before problems cascade. Even the track bed must be reinforced with specialized materials to absorb vibration and prevent long-term fatigue. Maintenance teams will need to operate with the precision of aerospace engineers, because even microscopic errors can lead to disaster. And yet, despite all of this, China is pressing forward. Because while the engineering challenges are enormous, the strategic rewards are even greater. This is no normal rail system. It's an infrastructure revolution, and China is proving that the future doesn't belong to the country with the best ideas. It belongs to the one that builds. And while China builds, the West debates. In the United States, the concept of vacuum tube transportation isn't new. Elon Musk proposed the Hyperloop in 2013, promising ultra-fast travel in sealed pods moving at near supersonic speeds. The idea captured headlines, drew venture capital, and sparked a wave of startups. But over a decade later, the US still doesn't have a single operational Hyperloop. Most projects are stalled in the prototype phase, if they're alive at all. Regulatory hurdles, fragmented infrastructure, lawsuits, and risk-averse politics have turned vision into vapor. Europe isn't faring much better. Ironically, Germany, the birthplace of Maglev, had the technology decades before China, but political infighting, short-term budgeting, and environmental opposition kept the system stuck in research labs. Despite having a successful prototype, they never scaled. The Trans-Rapid Maglev line, once Germany's technological crown jewel, was dismantled. The country that invented magnetic levitation walked away from it. Japan offers a partial exception. Its Chua Shinkansen Maglev is under construction, connecting Tokyo and Osaka with trains that will reach 375 miles per hour. That's fast, but still 245 miles per hour slower than China's goal. And despite Japan's engineering excellence, the project has faced delays, cost overruns, and regional opposition. The original 2027 target for opening the full route now looks shaky. Meanwhile, China didn't just copy Maglev technology, they built an ecosystem around it. Their approach wasn't about small wins or safe bets. It was national-scale investment. Entire research parks, test tracks, industrial manufacturing lines, and government-funded infrastructure were deployed to take this system from idea to reality. And China doesn't have to wait for private capital or shareholder votes. The government sees transportation as a national strategic asset. Just like energy or defense, that mindset allows them to commit billions to long-term projects that won't pay off for years. But when they do, the payoff is generational. So while American startups build test loops in the desert, China is laying full-scale tracks. While European officials debate cross-border standards, Chinese engineers are tuning their vacuum seals and prepping for commercial launch. In the 21st century, infrastructure is power, and China is quietly locking down an advantage the West can't match: speed at scale. Not just technological speed, but systemic speed of planning, building, adapting, and executing. In this new game, bureaucracy is a liability, debate is delay, and delay is defeat. While the US leans on legacy systems, airports built in the 70s, highways choked with freight, and a rail network designed for cargo, not people, China is laying down a new blueprint, one where travel is seamless, frictionless, and unbounded by the constraints of gravity or wind. They're not just building transportation, they're compressing geography, redrawing economic maps, collapsing travel times between production centers and financial hubs into mere minutes. And that should scare the West, because the infrastructure gap is no longer just about convenience. It's about global influence. Countries with better networks move more goods, attract more capital, and foster more innovation. Businesses go where things move faster. Investment follows velocity, and nations that control the flow of people, products, and data control the future. Yet again, China signals dominance with its Maglev project, and that it's not waiting for permission to lead the next era. It's building the foundation now, piece by piece, tube by tube, at a pace that no democratic bureaucracy can match. And while the West argues about feasibility, China's trains are already floating. carrying real passengers across real cities in real time. But here's the part almost no one's talking about. This 620 miles per hour train, it might soon be considered slow.